Hi, hello there. So today we're going to have a look at how to solve an inequality. So we know how to plot it on a number line, but how can you start with something that's a bit more complicated and work your way through to something that's a little bit simpler? So the process isn't as hard as you might think. Okay, stage one in the process is going to be to change the formula. So we'll have a look at that now. Let's take a very, very simple one. Okay, let's say we're asked to plot on a number line. Five x minus 3 greater than or equal to 12, and x is an element of the natural numbers. So how would we go about doing this? Well, we take it in two steps. Step one, of course, is to solve this. Step two, draw it. And that should work. Now let's do step one. Let's solve it. So we're going to treat this like we would treat a normal equal sign, with one exception, which I will come to. So if this was an equal sign, what would we do? Well, we would try and get the single variable on its own. So this is stuff that would have been done in first year, so we're just coming back to it now. We're just using an inequality this time. So what we would do would be as follows. We would add 3 to both sides in order to get rid of this 3. We would divide each side by 5 to get rid of this 5. So what have I done here? We're going to add 3 to both sides, and then we're going to divide by 5. So if I add 3 to both sides, I end up with this line. If I divide both sides by 5, I end up with this line. So now, how would I plot x greater than or equal to 3 on a number line if x is a natural number? Well, I need a number line, don't I? So this is where I get out my ruler. Now, assuming this is going to be drawn for you. Okay, so we'll start at 0 because we don't need to go, it's a natural number. There's 1, 2, 3, 4, 5. I'm just going to put an arrow going that way. Why? Greater than or equal to. It's going to the right. So how do I represent natural numbers on a number line? We use a solid dot. Greater than or equal to 3, that means a solid dot on the 3, on the 4, and on the 5. And there's your full marks. Okay? We'll try another one. So we're going to try another one just to get your head around this idea. So let's see. Okay, here we'll do another one. We're going to plot on a number line x minus 1 less than or equal to 4, and x is an element of the natural numbers. We go simple again with the natural numbers. Okay, so how do we do it? Step one, we need to get this formula where we only have the letter, the variable on one side. We're going to treat it like an equals. So I'm going to add 1 to both sides, add 1 to both sides. If I add 1 to this side, that one is gone. If I add 1 to this side, I get 5. So now I'm going to plot it. So there's 0. Why start at 0? Well, it's natural numbers we're dealing with. We don't have to go down past 0. 1, 2, 3, 4, 5. We'll just do 6 for the fun of it. So, natural numbers, that means we're dealing with dots. Less than or equal to, solid dot. Less than goes to the left. Why do I stop there? Why do I not include 0? Because 0 is not a natural number. And that's it. Okay, we can put the arrow going that way because we're looking at it this way. We're not looking that way. Okay? There's another example of it. We'll try another one. Let's say, okay, 2x plus 5 less than or equal to 1, and x is an element of the integers. Ooh, the integers. So step 1, let's solve this one. Okay, I'm going to take away 5 from both sides. So that's 2x less than or equal to minus 4. Okay, if I take away 5 from 1 is minus 4. Okay, step 2, look, I'm still left with a number attached to the variable. So to get rid of it, that's a multiplication. Did that in first year. We're going to divide both sides by 2. It's going to be x less than or equal to negative 2. So let's draw this. So there's 1, 0, minus 1, minus 2, minus 3. Now, less than means we're going to the left. Less than or equal to minus 2. So we're going to put a dot there and a dot there. Minus 1 doesn't get a dot because we're less than minus 2. So there's another example. Now, we're going to do a trickier example. We're going to do a trickier example now. Okay? So, have a look at this one. 1 minus 5x greater than negative 14, and x an element of the real numbers. So, what's our first step? Our first step is to tidy this up so we get a letter on one side. So, first thing to do, I'm going to take away 1 from both sides. Take away 1 from that, it'll just leave me with the 5x, because that one will be gone. And take away 1 from that, you get to 15. Okay. Now, this is where we have to be very careful. Okay? Because when we're looking at, and I'm trying to kind of get this into your head very early, okay? Usually, I would just divide both sides by negative 5. Like in the previous question, you divide both sides by plus 2 and it gets rid of the 5. Or, it gets rid of the number in front of the x. But inequalities are a little bit strange, okay? When you're dividing, okay, or multiplying by a negative number. So in this case, I'm trying to divide both sides by negative 5 to get rid of this. Okay, but because I'm dividing by a negative number, the symbol reverses. Okay, so that's quite important. Okay, it must be changed when both sides of an inequality are either multiplied or divided by the same negative number. So because I'm going to divide both sides by negative 5 to get rid of this, that leave me with x. That's going to leave me with 3 because minus 15 divided by negative 5 is positive 3. But this sign switches. The only time it has to happen is when you're dividing or multiplying both sides by a negative. Okay, so just be very careful of that. Just be very careful of that, okay? So, where is x less than 3 and x an element of the real numbers? Let's draw that then. Okay, so here we go. There's 3, 2, 1, 0, and less than means we're going to the left. So what? Less than 3 means we're not using the solid dot, we're using a circle, and because we're looking at the real numbers, we have to highlight the whole line up to that point. Okay? So that's a very tricky one. That's one to watch out for. Okay? When you multiply, we'll do another one of them now in a second just to show you. But when you multiply or divide both sides by a negative, you have to switch the symbol. It's the only time. So we'll have a look at one more, just like that. So have a look at this one. 4 minus 3x greater than minus 5, and x an element of the integer, so we need to draw it. Okay, so we'll do our first things first. Let's try and get the x on its own. I'm going to take away 4 from both sides. So that's minus 3x. So I'm taking away 4 from both sides. Okay, if I take away 4 from 4, it's 0. If I take away 4 from 5, I'm minus 9. Now, I'm going to have to divide both sides by negative 3 to get rid of this one. But because I'm dividing both sides by a negative, that'll be grand, but this switches around. X an element of the integers. Let's draw this. So, starting at 3, 2, 1, 0, minus 1, and we're going in this direction because we're going less than. So, less than means circle, okay? Now, you didn't have to put the circle, but I put it there anyway. You could actually leave it out because it's less than 3. The next integer possible would be 2. It wouldn't be anything there, but actually you don't need that. Probably a mistake for me to draw that. I can't take it out now, but there's no need to put the circle there. Okay, we're starting at 2. Okay, so hope that helps. Yeah.